Time for some more programming, and this time it's a bit different. This time I'm not gonna directly be working on the Streamerverse project. I'm going to be trying out something that I think will help improve the project. I don't know for certain yet. I've never used this before, and I'm going to try around with it, play around with it, see how it goes, and hopefully, if nothing else, I'll learn something new about Postgres databases. But the biggest benefit of this is I'll be able to replace my database, my Postgres database, with a more efficient, faster version of it. So that'd be the hope. But to be a bit more specific, what I'm going to be doing today is be checking out a Postgres extension called TimescaleDB. And TimescaleDB is basically just Postgres that's been finely tuned to work specifically with time series data. And now time series data is just data that's very time specific. So for example, weather data, like weather is based on the time of day at which you are viewing it at. Like the weather right now in Seattle is pretty rainy. It's overcast and a little rain. That's at around like 9 p.m. If I just said it's rainy and you had no context of the day or the time, that doesn't really make sense. So that's kind of what I'm going to be hoping to do with Timescale, because my data is extremely time sensitive as well. I fetch viewers every hour for the various streamers, and I insert that into a database. And then calculating all the different number of viewers, streamers compared viewership every hour for every week. It's computationally pretty expensive, and if I can get a database that can help me speed some of these operations up, I would really enjoy that. I would really like to have that, because right now I cache basically the results before putting it up live on the site, and I'd rather that be more of a live view of the data. So let me go ahead and change this in the scene. And I've already set it up. I've already installed Timescale. I had to install Postgres 13 because they do support 11, but they don't recommend it anymore because 12 and 13 are the new versions of Postgres. And so I downloaded a version 13 of Postgres just to play around with. Holy shit, they got loud really quick. So yeah, I downloaded it, installed it, and I've set up a test project here, Timescale, that I'm going to just play around in and just try it out. And maybe later on I'll try to import some of my old data. Oh, okay, I can't just do that apparently. I'll import some of my old data from here. You can see I've got 3 tables. This is from yesterday. 3 tables full of data that I could import into 13 and just play around with it more accurately to what I'd be seeing in the live version of my project. So let's go ahead and see how. Okay. So it uses something called PGX driver for talking with the Postgres Timescale database. I'm probably going to use Postgres and Timescale interchangeably, but just know that I'm always referring to Timescale in this instance because they're essentially the one and the same. So they're using a connection URL, which I don't want to show you because obviously I'm not going to show off password and username and host and port. So it looks like the first thing I'm going to have to do, as always, is a simple config. I'll have to create a simple config reader. Okay. And this will have the connection URL, which is a string. I'll just call this actually just the database URL. Or DSN, I think is the proper name for it, so I'll just call it that. Load. And then I have a global config. There we go. Now, let's see. F error OS open config.json. Error is not equal to nil. Error. Then return error. Otherwise, defer f.close. And then JSON new decoder f dot decode that into config. And actually, I guess into config. And let's change this actually to initialize it with the defaults. So this way I don't have to redefine it again each time. And then return. So, okay, so this will go through, this will close it, this will decode it into this, and then this returns an error. So if there is an error, it will call it back. Cool, simple enough. Let me go ahead and create a config.json file, and then DSN, and then this is what it will look. This is what it will look like. SSL mode, I think it's disabled. And okay, I'll change the rest of this off screen because I don't want you to know what my username and password is. Okay, if error config. Oh, right, I didn't export it. There we go. No panic error. And then let's create a context. Context.background. Then connection error pgx.connect context and config dot looks like this is not accurate anymore. Yeah, connect is different from what it used to be from this doc example. Let's see what PGX has for terms of parse connection string, parse DSN. What's the difference between these? Parses a database DSN into a config, parse DSN. Okay, no, we're not using a DSN, we're using a parse URI. What's URI like? Connection string? What does this look like? Okay, example URL. Okay, so parse URI. Okay, so really just call parse URI, and then config.dsn. Technically, it's not a DSN then, so I should rename this. Rename this to dburi. Then do the same here. dburi. and then this will return. Ooh, what is this called? Con config cc or error. Error is not equal to nil. We panic. Otherwise, we take this, pass it down here. Connection errors out. We also panic. And then we can defer con dot close. Do I need to pass anything to this? No. Yeah, it's pretty outdated, some of this stuff in here. Whatever. I haven't needed this so far, so I'll get rid of it for now. And let's see what it returns to us. Select hello timescale. And then scan that into out. Check the error as always. Favorite Go syntax, so just always checking errors. And then finally format.println out. Okay, so this should be a basic example of connecting to the database and it returning just a hello text right back at us. So let me go ahead and pull this off screen and input my username and password for my database. What's the default database in Postgres? Ugh, got it. Always gotta do something. Keep forgetting. Databases. Okay, it's just called Postgres. Whoops. Okay, that should do it. That should be everything to connect to this database. I'm connecting to just my default Postgres 13 database. There's nothing in it. It's completely empty. So it should be fine. Let's go ahead and give this a run, see what happens. Or actually I should just do the project. I really hope. Oh. Wow, thank you. Jesus. That was great. Well, I'm gonna have to scrub this later. Okay, there we go. Cool. It worked. Fuck, I showed it again. Whatever. So there you go. It worked. It was able to enter. It was able to query the row, and then it was able to push it back out. So that's good. Easy enough. Didn't expect that to do anything. All right. One thing I probably will change is I probably won't use PGX. I'll probably use GoPG. PGX is like really low level. It's supposed to be a hyper performant kind of a library, like just the bare bones of Postgres connections, SQL connections, and GoPG is more of an ORM, so I'll probably use GoPG because it has all the features of PGX, just a bit more extension on top of them. Yeah. What's this? Connecting using a pool is useful if you don't want to waste resources and can lead to faster cruising. To create a connection pool useful for concurrent, to be used for concurrent connections to your database, use GoPGX instead of GoPG Connect. As used in the example program below. So he uses GoPGX pool. I'll just stick with this because I'm not trying to do anything specific. Okay, create a table. To create a table, ID, primary key, type, var, location. Okay, execute the query. So connect to the database and then create a relational table called sensors. Okay, so sensors is just a normal table, it looks like, with ID, which is a serial, type, which is a char, and then location. Nothing too fancy there. So this is where the cool part comes in, where it generates a hypertable. So hypertables are, well, I'll read this. The primary point of interaction with our data is a hypertable, the abstraction of a single continuous table across all space and time intervals, such that one can query it via standard SQL. Virtually all interactions with Timescale DB are with hypertables, creating tables, indexes, altering tables, inserting, yada yada yada, all beyond hypertables. Okay, so, and this is how they define a hypertable. First we create a variable which houses our create table statement for our hypertable. Notice how the hypertables have compulsory time column. Second, we formulate the select statement to convert the table created into a hypertable. Okay, so here you can see they create a sensor table with time and some other data. Then they change the table into a hypertable. Okay. So in my case, I want to change my viewers table into a hypertable. So let's see. So let's go back up here to this example. Let's get rid of this. Now let's do create table SQL. Okay, and then let's go back down here. Just copy what they have for now. Alright, so create table sensor data. I want to create viewers table with time. So they're using timestamps. I wonder if I have to change all of my data into timestamps finally, because currently I'm using an ISO week, which is basically just a bar chart. It's not really the time. It's not an actual time scale. Or a time scale, actual timestamp. Probably. Okay, so timescale, streamer ID, which is a big int, and or not streamer. The streamer ID is just a string or text, and then viewer. Well, I think it's just called ID. So yeah, just ID, which is a big int. And let's just check posts, or maybe they have their own types. Let's see, TimescaleDB types. Designing proper tables is creating proper indexes. Timescale supports all data, including okay. Okay, so it's exactly the same as Postgres types, so I don't have to worry about that. So Postgres types. Postgres 13 types to be specific. Yeah, I think it's just a big int. Okay, cool. So just a big int, and then I don't have either of these. And then we take viewers, split it on time. Okay, so second we formulate the select statement to convert the table created into a hypertable. Note that we specify the table name which we wish to convert to a hypertable and the column name as and its time column as the two arguments, as mandated by the create hypertable docs. Okay. So required is the relation, which is the table name, and the time column. A name of column containing time values as well as the primary column to partition by. Name of an additional column to partition. Name of an additional column to partition by, provided the number partition argument must also be provided. Okay. I might be able to do double partitioning then, because obviously right now I only partition on time in my main database here. As you can see, I have different partition tables by time, but it might be nice to actually have another table for streamers, specifically streamers. That's a lot of, that's like 1,000 tables though. Is that efficient? I don't know if that's efficient, having a lot of tables in Postgres. Is good old Google will tell me, is having oh, sorry, I had a cough. Is having a lot of tables. Wait, what was that? A lot of gas bad? Fuck Google, why you do this to me? Broxton hiccup? What are these searches? Okay. Is having a lot of Postgres tables bad, let's just say. Does have a limit on the number of tables, however each table is a file in the US. This probably has its opinion of how many files to any particular link says open the file and you can view it. Okay. Okay, so each file or each table is just another file. Is having a lot of posts. You don't have to keep a million files in there. You can use create space to arrange space in a different directory or even different disk. I don't even know anything about. What is the current? Okay, so six figure. That's 100,000. I don't think I'm gonna get to 100,000 tables. Like, there's 2,000 streamers, and each streamer will have its own table essentially. So I'm only getting to like 4 figures, or yeah, 4-figure number of tables, which shouldn't be that bad, I think. Planning overhead goes up as the number of tables in DB goes up by a. If anything larger than planning time. Alright, for now I won't try to partition it further. I'll just keep it on just time. And again, another thing is I have to convert the ISO timestamps into like actual time dates. What are the other properties? Create default indexes if not exist. Okay, partitioning func. Data nodes. This is the set of data nodes that will be used for this table. If it distributed, this has no impact on non-distributed hypertables. If data, okay, I don't care about that then. Replication factor. Yeah, I don't have any replication. Okay, so for the most part, it seems fine. Use of migrate data, no. The time column supports the following: time, timestamp, date, integer. Okay. Looks like I'm wondering if I can convert. I could I know I can convert. I'm just wondering how I'm gonna do this. Convert each one of the ISO weeks into an actual date time. It'll just be the Monday basically. Every single ISO week will be converted to the Monday of that week, and then yeah. Wouldn't be that. Well, actually, it'd be kind of hard. I don't know. Maybe not really. I'm just trying to think how I'm gonna convert it though, because like there's a lot of rows. Converting every single row in like one of these tables to like the actual date time. Oh god, that'll be annoying. I could probably write like a Postgres function to do it for me. Yeah, I might have to. We'll see. Okay, so for now, what's timestamps? Timestamp. What is? Ooh, okay, what is this? Is this Postgres data type with timestamp? I think this is with timestamp. I think this is what this is. Okay. SQL standard requires that writing just timestamp be equivalent to timestamp without time zone in Postgres runs that behavior. Timestamp Z is accepted as an arbitration for timestamp with time zones. Okay, so it has a time zone. Do I need a time zone? Not really, because I'm kind of assuming it's always the same. Ah, whatever, I don't care. They can have the timestamp for all I give a crap. Okay, and then, so that's the SQL to create the table. Now we need to actually run it. Connection dot execute create table SQL. Yeah, that's just about it, really. Error is not equal to nil. We panic. Otherwise, format. What does it say? Okay, that just doesn't matter. It's just a line to say it did it successfully. If it doesn't print anything, I know it worked. That's basically it. So just short line. I'll do this here. There. And I'll be able to see it in here too. So let's give it a shot. So create table viewers, timestamps, stream ID text, big end, and it's that's. Let me just check. I guess. Be extra careful. Is it actually like that? Let's see. Properties. Dashboard? No. I think it was properties. I think I was right the first time. Yes, it is. Okay. Yeah, it's just text. Cool. And time ISO week is going to be replaced with timestamps, an actual timestamp date. Oh, I guess that's one thing. How is it going to partition it? Like, what's the like time frame? Because I want it every 7 days, basically, to partition it. Partition func. Okay. Func to convert incomplete primary time data with compatible ones. The function must be immutable. Oh. Oh. Ooh. I just thought maybe I could use this. Function to convert incomplete primary time column values to compatible ones. This function must be immutable. I could create a partition function that basically just takes all the ISO weeks and converts it into their respective dates. I could do that. I could maybe do that. Chunk time interval. I think this is it. Event time that each chunk covers must be 0 as of timescale 11. Default is 7 days. For previous version, default is 1 month. So every 7 days. Okay. Time chunk interval. So I go down here to this example. So every day is a different chunk in this example here, whereas for the default it's 7 days. Yeah, that's what I want. Every 7 days. I hope that would. Well, I can give it a shot. I can try inserting the data and seeing what it looks like once it's inserted. Let's give it a shot, I guess. Let's just run it, see what happens. If it breaks, so be it. It broke. Cool. Okay, syntax at SQL statement. Which one of these is the problem? Not sure entirely. Let's scroll back up, or I guess it's over here. Let's see which one of these is causing the problem. Ah, I see. No comma. Beautiful. If not exists. Or I guess it's actually like that. I'm worried that it might be connecting to the wrong database. Looks like it might be. Localhost 533. Oh yeah, I see what's going on. Okay, I gotta change the connection port. Uh, 5433, yeah. This should be it. I wonder if it installed properly. Admin pack, that. Wait, did it install it up here? Oh, you son of a bitch, it did. It installed it in Postgres 11. God damn it. It installed it up here in Postgres 11 instead of down in Postgres 13. Beautiful. Just beautiful. Okay. Well, let's open this again, I guess. Can I execute it just right on top? Let's see. Let's see if this will work. Yeah, okay, that doesn't work. Bruh. Okay, getting started. Overview. No, I don't want to create a forge. Stop asking me to do that. How to, guys, install Timescale. I feel like This is annoying. I think it installed it up here. Is there any way for me to find out where it went? I don't know where it is right now. I feel like it's... Like it won't show me this, which is concerning, I guess. A standard 13. Make sure all the relevant binaries are in your path. Use pgconfig. What does this do? I guess I'll open up CMD and check pgconfig. Okay. I guess that proves it. I'm not really sure what I'm gonna do now because this is not installed, it seems. And I guess I could try installing it again and see what happens. Like it should have been. Let me go ahead and pull this up. Great. Download the file, extract locally, run system, and make sure that PostgreSQL is not currently running. I know it is right now. How do I stop it though, I guess is the question. Beautiful. Yes, I feel like wait, I guess I can figure out something. Yeah, there it is. God damn it. Let's see actually what happens if I delete this and then run this again. Didn't create any viewers. Did it go here? Create table of non-exist viewers. Where's it connecting to? I'm so confused now. The fuck? I think I think it's trying to do that all in one transaction, so I guess that might make sense why it's failing. Give it a shot, I guess. I'll This is gonna suck. And then data. Oh, you've got to be fucking with me. What's Postgres? 13 data. That's right. I have the privileges and you don't. Okay. PGCTL. Scripts. Bin. PGCTL. Okay, there it is. Yeah. So CD up, or no, fuck. CD 13. CD bin. PGCTL. Okay, PGCTL. We shall stop the service. Actually, let's just restart it. Maybe, because I didn't restart it after I installed it, so maybe. Maybe all I need to do is restart it. Okay, shutting down, server stop, waiting for server start. Okay. Oh, no, I wrote it right. Postgres 13 slash. I think I wrote it right. Properties, CD Postgres. Copy. Let's try it again, I guess. Jesus Christ. How many times am I going to forget to do this? Is this running right now, or did it get conked? It got conked. Okay. So it is actually down right now. Beautiful. Windows key R sir. This is .mcs. Okay, there we go. Trying to start it. Postgres service on local computer started and then stopped. I don't think it will. Well, is this one still running? It does not look like that one's running either. It looks like both 11 and 13 are down right now. Oh, it just looks like the entire thing's down right now. Why can't it? Could not access directory. No such file. That doesn't make a lot of sense to me. I'm on administrator. I know it exists. Alright, fine. Fuck off. I wonder if it's because the space. I wonder if it just doesn't like the spacing. I think that might be it. It might just be the spacing and the name. Another thing I can check is just run on data. Bin. Where's the config file? There's the script to start the server, but I don't think I should just run that arbitrarily. Let's see what the config file looks like. Do I not have Sublime? Oh, this is gonna be annoying. Thought I had Sublime on here. I do, yeah, okay. There we go. Time Scale DB, okay. So it's definitely there. TimescaleDB is there. Change requires a restart. Yeah, I thought so. Okay, so it did require a restart. What if I just don't say the... What if I just tell it to start? No database directly specified environment should be PG. Okay. Dash dash help. Let's just see what it looks like. Yeah, it looks like just database mode. Okay, so I do need dash D. Jesus. Dash D. And then it should be a pointer to the directory. Go up one and then it's just data. Like it's literally just called, or it's just data. Oh, that worked for some reason. Could not access file time. No such file or directory. Let's see. Could not access file time. Could I? Okay. You should double check the tabs have been installed to the correct location. Our installation method uses CoPG to check location. However, if your multiple version is on the same machine, the location points to may not be the very version you expect to check. Okay. Config. I don't think, yeah. Okay, so this is where it's pointing to, but if I were to back out one step and then go PG, yeah, it's not, doesn't run anything. So if I go down one step, or bin, .3, okay. I'm wondering if it didn't do, I don't think it installed properly, yeah. I think it's missing some files. I think it definitely is missing some files. So I think what needs to happen is I need to, okay. Edit the system variables. Key. Let's browse to this PC, C, program files, Postgres 13 bin. Okay. Okay, and then if I were to close this, CMD, run it again. Yeah, PG config dash version. Really? Didn't update or 13 bin PG config. It's in here, right? I thought I saw it. Yeah, PG config. PG. Really? I just updated the system variables. Why isn't that being propagated? Maybe restart it again. Let's see. There we go. Okay, yeah. Easy. Alright, now that that's installed, we have to, I guess, just install it one more time. Extract here. Open this. Run as administrator. Cool. Oh, no, what the hell? Bring all this back to the front. Yes. I guess this is my tutorial on how to install TimescaleDB as well, so congratulations. You're getting both debugging and usage out of this one stream. Okay, enter the path to the Postgres conf. Program files. The hell is it? Postgres 13 data. Copy. Slash Postgres QL dot conf. Saving changes, installing libraries. Okay, maybe this time it installed properly. Let's give it a shot. PGCTL -D. start. Ah, there we go. Now if I go to PG admin, let me log in. Yay, there we go. It's installed, or it's up and running. And then if I were to refresh this, I don't know if it actually installed though. I think it did. Is this still running? Ugh, joy. Okay, yeah, this is up and running too. Still won't open. Whatever. Or don't leave. Alright, let's try running the arbitrary code. Or I'll just run the program and see what happens. Still doesn't know what that is. Odd. I'm fairly certain I updated this. Sure, we'll say always open it. Yeah, okay, it's in there. Doesn't know what that is. Let's see. Function create hypertable does not exist. Let's try that. Oh, okay. I guess I have to run that. I like how the timescale docs don't say this. And Postgres query tool. Okay, welcome to. Okay, maybe now it worked. Okay, it's installed, so let's give it a shot. Oh shit, that ran. There it is, boys. I did it. I did it, buddy. Oh, fuck me. That was annoying. Okay, so it's installed now. Bit more complicated than I thought it'd be, but hey, it's there now. I have the Timescale database. Let's try inserting some data into it, I guess, now. Oh, whoops. I closed the wrong tab. This one. Golang. Did it say anything about that? Didn't really say. Whatever. Generate a hypertable. Here we go. Okay, so I create the hypertable. Insert a row into your Timescale database. Here's a typical pattern you'd use to insert some data into a table. In the examples below, we insert the relational data from two arrays, sensor types, and sensor locations in the relational table sensors. First, you open up a connection, and then it inserts a couple of different sensors. What's this? Generate sample time series data insert. Okay, this seems to just batch insert a lot of crap. execute a query. If you're interacting data, inserting data from CSV, use the timescale parallel copy tool, which is a command line parallelizing. Okay, that's interesting. But I want to. For simplest sake, we'll use PostgreSQL to generate some sample time series data in order to insert into the define SQL statement to generate the data called query data generation. Oh, so it's I see what it's doing. Okay, they're just using Postgres to generate some random data to insert into the database. That's interesting. And then takes all that data. Then they just insert it all. Okay. What do I want to do though? I already have some data. I could export one of my partitions from here, from Postgres 13. Still doesn't want to do that. Don't know why. This one open? No. Cool. I could export one of these partitions and then try to insert it and see what happens. Let's see, can I export it just from here? One annoying thing though is that I'd have to convert some of this data. Maybe I should call the stream for today, and then just tomorrow I'll do some more timescale stuff, play around with it. I'll just get I'll get the data ready to insert for tomorrow, because I don't really know, because I'll need to format the data to insert it properly, because again this is using a timestamp, whereas streamer ID and ID. So I gotta convert this ISO week. I think that might be the better way to do this, because I don't know if I really want to spend the next couple of minutes exporting and then converting the data on stream, because that seems kind of boring to me. I think this stream's also already kind of fucked, to be honest. Wasn't the best stream in my opinion, but is what it is. Yeah, I think I'll call it quits for today, and then tomorrow I'll have the data ready to be inserted into the Timescale database to give it a shot, see what happens. And then I'll be able to play around with it a bit more tomorrow, just to see how the performance is and everything. But I'm glad I was able to get Timescale working, I was able to create the database, and I was able to create the hypertable. I don't see what that looks like in pgadmin, so I'm not really sure what that means. Oh, there they are. There's some other stuff up there. There's a lot of different schemas, for sure. Casts, catalogs, events, some events, languages, publications, subscriptions? No. Okay, but there's... So I've got this one table of viewers, and I don't know what these other schemas are. I imagine they're for inserting. Oh, hypertable? Maybe. Well, I'll give it a shot tomorrow. Yeah, I think I'll just call it quits for today and get the data ready for insert tomorrow. I'll probably test, obviously, inserting it before I go live, because that would suck if I didn't do that ahead of time. But tomorrow, more just playing around with Timescale, and then over the week I'll probably actually do the full implementation. Maybe, or I might just do it on the next weekend after. But I did reach out to Solinome to get his to ask for permission to use an API. Hopefully he gets back to me. But that's about it for today. Sorry how shitty this stream was. If you're watching, God bless you. You're a real champ. I'll see you guys tomorrow. Bye.